The first thing that we were going to do today, well, the first and only thing that we're going to do today, unless there questions come up, is we're just going to go over the exam that everybody hopefully took. I looked and lots of very decent grades on the exam, but there were some things that tripped people up, and a few of them were intentional tricks, and we'll go over that so that hopefully next one won't get you. A couple things to go over though. I did release the lab today, so that's out there, Lab 9. It is a bigger lab, so I suggest getting started ASAP, but it's also not due until next Sunday night, so you got plenty of time. But like I said, it is a bit more work, so I suggest getting started as soon as possible. Uh, the project, I will hand that out at some point this week. We're still revising some stuff on it, so it's not quite ready yet, but this week it'll be handed out, and I believe that it'll be due at the end of the semester. So, again, you'll have plenty of time with that, but there'll be a lot of stuff, a lot of concepts, and a lot of moving parts in this. So that's the goal. Okay. Now, any questions before I get started? All right then, let us get started. On the exam. So the first question that we asked was actually a three-parter here. So uh, first, give the symbols for the six relational comparison operators found in C++. Well, that one didn't trip up like anybody. That is the greater than, the less than, the greater than equal to, the less than equal to, the equals, and the not equals. So that's all six of them. And now define short circuit evaluation. Well, rather than write this out because this will be painful, we'll just say that defining short circuit evaluation is if you can if you can determine the result without evaluating the whole expression, that's short circuit evaluation. It's where you know the answer before computing the whole answer. So the computer has to be able to skip evaluation of something, and we call that short circuit evaluation. Now, the three types of if statements that we talked about in class, well, that's just a regular if, a single alternative if, and then a multi-alternative if. All right, any questions about this first part? Like I said, everybody generally did really well on this first part, which was great. Next, we have some logical expressions and determining whether or not short circuit evaluation occurred or not. So the first one here, K, which is 38, so I'm going to write a 38 right here. So we say 38 is greater than 17. Well, that's true. So let's go ahead and write a T right here. So that's true. So true and M equals the 70. Well, a true with an and statement, we can't short circuit evaluate that, so we have to evaluate the right side and see if that's true. And M is 76. So 76 is 76 equal to 70? Well, that's false. So a true and a false? The answer is a false. Short circuit evaluation? No, we didn't have any. So number 2, letter A is capital A greater than capital W. Now, hopefully, we didn't even throw any trickery in here about capital versus lowercase letters, but A is less than W because W comes after A, so it has a larger value. So That is false. So this whole thing evaluates to false. Or, so a false or, that means that we have to evaluate the right side of the expression as well. We can't short circuit this. Whoops. And we say x, 3.1416 float, does not equal 3.14. Well, that's true. We know that much at least between these two numbers, right? So this whole thing evaluates to true. So false or a true, that is a true. And there is no short circuit evaluation. Now this one, let's see here. K is 38. So 38 greater than 20. Well, that's true. But then we not this whole thing. So this whole thing turns into a false. False and anything is a false. So this whole thing is a false. False or. Okay, now we have to evaluate the right side, but notice that we did do some short circuit evaluation here, so I'm going to say that we did short circuit something before I forget. Now we say, is M, or 76, greater than 38 times 2? 38 times 2 is 76, so that's false. So that ends up being false. Next, we say X is less than or equal to 40. Well, that's true. So we have a true or some value. A true or some value. Well, that value doesn't matter. This whole thing just evaluates into true because of short circuit evaluation, right? And then I'm going to write a true here for short circuit evaluation. And so we have a true. Sorry, this one's getting a little messy here. We have a true and K is greater than 20, greater than or equal to 20. So since we have a true and we have to evaluate the right side of the expression, we can't short circuit this part. So then we say, is 38 greater than or equal to 20? That's true. So a true and a true equals a true. Next, we have, is K equal to 5? Ooh, but look at this. This is the trickery right here. This is not a double equals. This is assignment. This evaluates to true all the time. So K gets 5. K is 5 now. This evaluates to true. True or, and this whole thing is wrapped in parentheses, right? This parentheses goes all the way over here with this parentheses. So true or this whole expression. So this whole expression doesn't matter. We're going to short circuit this and just evaluate the whole thing to true. And short circuit did happen. Any questions on any of these problems?
You got me on that last one.
I know. And it's not going to be the last time that this comes up, even on this exam. This equals sign, make sure to look out for it. Like, if I was in a hurry, it would have got me too. So don't feel bad by any means. Oh, and just double checking. Everybody understands completely how we got here, right?
Yeah.
Okay. All right. And so, like I said, a few people got a few of these wrong. Not too big of a deal. It was mainly like, roughly one wrong per person. Here though, I was very happy. No, like hardly anybody got these two wrong. So convert the following mathematical expressions to syntactically correct C++ statements. So we just write answer equals, And then now if we wanted to do r to the 77th power, well, we have a function for that. Pow r 77. That's it. Now when we look at number 2, we see C gets some value, and this value is, let's just start with the pows. Let's do pow a to the second power plus pow b to the second power. And then we want to square root this whole thing. So SQRT, square root it. And we're done. And does that make sense? Any questions on that?
No.
All right. It seemed like everybody understood those. All right. Now in this one, definitely going to need some more room here. So what type of variable is in file? Now this one tripped a few people up. What we were looking for was, what was the data type? What was the data type of the variable in file? And it was an IF stream. Because it's an input file, so we wanted you to get that from looking at the variable name, saying, oh, that's an in file, and we're opening it to read from it. So this is an IF stream variable. Because you would have had to have declared IF stream space in file before this line where we opened it. Number 2, in programming terminology, what would .open be called? Well, the one word that we've talked a lot about is function. And that would have been a completely acceptable answer. In fact, it's the one that I expected the most. Or we talked a little bit about method. Either one would have been correct. Just for the record, method slightly more correct, but that's fine. We're not really talking about methods. Function is where it's at. Three, what library is .open found in? Well, where is ifstream found in? That would be, you could have written the whole pound include, but really it's just the fstream library. Stands for file stream. It's what we need to import in order to use any sort of file manipulation. What is the name of the file variable? Well, so this one, I saw a few people put like test.dat and like, oh, okay, I can see where that kind of confusion comes in. But what we're looking for is there is a variable here. Technically, it's this in file is a variable that is the file. So what is the name of the file variable? Well, it's just in file. And then lastly, we need to write a syntactically correct C++ statement to extract a variable from the input file and store it in the variable score, assuming score has already been declared. So we're saying pretend like score is already declared. It doesn't matter what the data type is. How do we read something from the file? Well, just like we would do if we had a cin to get from the keyboard, we would just write our extraction operator and score, like so. Now, any questions about that section? All right. So this next part, just a little bit of reading input from the keyboard here. Show the contents of each variable after the following statements are executed. Assume that each variable has been declared and is of the data type specified by its name. If the stream enters fail state, be sure to specify that. Okay, so this is the input from the user. Remember, underscores are denoted as blanks. So if we read a CN string 1, we start here and we're going to keep reading until we hit a white space character. So for string 1, we get this, which is 1, 2, 3.456 string. And then, so we're pointing right here at the space. Now when we get to string 2, remember, it consumes all leading white space characters, and then we'll start reading as soon as it gets to characters until it hits the next set of white space. So string 2, it's going to read A, B, C, D, and then we'll be right here. So string 2 contains A, B, C, D. And then we read char 1. Well, we're right here. So we will skip the white space. We're right here now, over top of the minus sign. And we store that in char 1. Because remember, a char can only hold one character, so we get just that one character. And then now we are right over the 3. So next, we do a cn.ignore. So now we're going to start ignoring 5 characters or until we get to a hyphen. So we're going to ignore 1, 2, 3. It's a hyphen, so we ignore that and then we stop. We stop ignoring because we hit the hyphen before we hit the total of 5 characters. Now, cn.get. .get is different. It doesn't make a difference here, but it is different in the fact that it's white space insensitive. Remember that. So char 2 ends up being 2. Now, any questions on that one before I move on? All right. So this next one, sorry, this is a completely separate problem. So let me just put a line right there so that I don't get mixed up. Cn int 1. So int 1, we're starting right here, and we're going to read all of the integer characters until we get to a white space or any non-integer character, basically. Anything that can be stored in an int. So 1, 2, 3. So this becomes 1, 2, 3. And then now we're right here over the top of the decimal place. And then we try to read int 2. Now a decimal can't go into an integer. This isn't a float, this isn't a char, this isn't a string. We can't store this in there. So we go into input failure.
So it doesn't truncate?
No, there's nothing to truncate. It can't just skip this, so it's going to try to shove the decimal in there. It can't go in there, so we go into input failure. And now when we go into input failure, though, we know that it stays in input failure for the rest of the program, right? So that means that string 1 is input failure as well. Or you could have put empty string and you could have put garbage here. As long as you said that somewhere in here that it went into input failure and that's why this was garbage and this was an empty string, that would have been fine. Yeah, okay. Andrew, did you have another question about that? Or
No, I'm good.
okay. I just wanted to make sure I got that whole thought out there. Okay, so now this next one, though, this next one's a little different because we're going to see in a float. So we're going to start right here at the start of our input, and we're going to keep reading, and we're going to read 1, 2, 3, dot. And now remember, a float, we can read the first decimal that we come across, and we can keep going. So 1, 2, 3, dot, 4, 5, 6. All read into float 1, and then we get to the space. Well, a space can't be stored into a float, so we're done. That's it. 1, 2, 3, dot, 4, 5, 6. And then we are right over top of the space, and then we do cn.get char1. Now, when we do this cn.get char1, it is white space insensitive because we're using get. So we're just going to get the space. So space. And now we are over top of the A. And then we cin char2. Well, there is no leading space here to consume, so it's going to just get the A. So the A character goes into char2. And then we cin string 2. Well, string 2, we're now over top of the B because we just consumed the A. So string 2 starts at the B and keeps reading until it gets to a white space. So B, C, D. Like that. And then now we are over top of this space. Then we cin string 3. Now this is a cin with the extraction operator, so we ignore the leading white space, and now we're here. So we read this whole string into string 3. So this ends up becoming negative 31 dash 2245. Now, any questions on that one? All right. Now we get to some good ones. Given the following pseudocode, pay attention to the indentation. So this is important here about when this is indented, that it's part of what's above it. So get years at work and job code from user via screen/keyboard input. So we know that we got to do couts and cins. Okay. If job code is 6, 8, or 10, then if years at work is at least 5, print eligible for maximum benefits. Now, paying attention to the indentation, this else is associated with this if. So, if the job code is not 6, 8, or 10, then we print not an appropriate job code. Now, some people took it to if the job code is not equal to 6, 8, or 10, and the years at work is not at least 5, then they print out not appropriate job code. But no. If you look at the pseudocode says only if the job code is not 6, 8, or 10, then you go into the else block, not an appropriate job code. It has nothing to do with years at work. Okay? So, we can assume that all necessary libraries have been included, and we need to implement the pseudocode for full credit. Do not simply rewrite the logic. So we can't change this. We have to write this as valid C++. So we'll write our cout statement. We'll do a cout, and we'll say, please enter years worked. Nice little end line there. And then we will cin our years at work. And then now we'll ask the user to input their job code. Oops. And then we'll get that input from the keyboard. So we cin job code. Okay. So we've got the input from the user. We've done this part of the pseudocode. Now, this requires an if statement. And our if statement's practically written for us right here. So we do an if job code equals 6, or job code equals 8, or job code equals 10. So if any of those things are true, then we go into this if statement. I'll just put my parentheses right there. Else, so I'll go ahead and write my else right here. And we'll write our C out here. Just get this out of the way. Not an appropriate job code. Okay, now let's go inside and handle. So we've handled basically this if statement, this else, and this print. So now we got to handle everything inside of this if statement. So if we go in here, we can see this is if year's work is at least 5, So if something's at least 5, then that means that years at work is greater than or equal to 5. If years at work is greater than or equal to 5, then we print eligible for maximum benefits. So that's it. See out. All right, and there we go. We've implemented all of the pseudocode. We've done every single line here. Any questions about this exercise? No? All right. Move on to the next one. So the next one here, answer the questions below and write the next necessary to accomplish the task. Be sure to use proper indentation. Comments are not necessary. So we need to create a function named printDistanceMessage, which has one parameter. It should evaluate the contents of its parameter and print, and that's the key word right there. It's all caps. Print an appropriate message depending on its contents. The parameter is int miles remain, which contains the number of remaining miles between Montreal and Queensbury, New York. Assume the variable already contains the value to be evaluated and all necessary libraries have been included. So we're just saying wave your hands, pretend like everything else is already all set up for you. Write the code as efficiently as possible. This one was important. Lots of people seem to get a few points off because it wasn't as efficient as possible. So, code the prototype below. Well, we got some keywords here, such as this will print the appropriate message. So this is a void function, because it's not going to return the message, it's just going to print the message. Okay, the function is called printDistanceMessage. And it should have one parameter. The parameter is int miles remain. So right here. So our parameter is int miles remain. And this is the prototype, so we just put a semicolon. Cool. Now where does the prototype appear? Above main. Code the call in the space below. So assume the variable already contains the value to be assessed. Bleh. Where's the name of the... Well, let's assume that we already have a variable called miles. So we're going to say code the call to be print distance message miles. So that is the call that we would do to invoke the function. Where would you find the call? In main or also another function, because a function can call a function. But generally, that's the answer that we're looking for, was in main.
Can you use a parameter as a function? A function as a parameter, rather, in C++?
You can, but then you get into pointers and things like that, which I'm not going to get into that here. So, because you can use that a function that you pass into another function and use that to invoke the function and all that stuff, which I'm sure that you've seen that in JavaScript, and that's why that comes up. Right?
Yep.
Yeah.
Exactly.
Let's just say it's a lot easier to do in JavaScript than it is in C++.
Yeah, you just type it out.
Yeah, it's not quite that simple here. But it has to do with strongly typed and all that stuff. So where would you find the function definition? Well, what we were looking for was, it's our best practice to put this below main. And then now we're asked to code the function definition. So if we look up here at what was asked of us, I'm going to try to keep this on screen, but it's going to be a little difficult here. So we need to print out one of these messages based on the miles remaining. So let's start with our function header really quick. So we got void print distance message int miles remain, open curly brace. And then now we need to ask some if statements. And this is what got a few people tripped up, because we said where we wanted to be the most efficient. And remember how we were talking about, like, think of it as a number line. So we have like this number line here where we say, and these are inclusive. All of these are inclusive. So if we had 150 and then this is up, right? So we want 150 and up, or excuse me, I did that wrong. 150 exclusively. So we want it, exclusively, yes. So not 150, but we want 151 and so on and so forth. That should be let's roll. But then if we look at what's the next number that goes below that, well, that's 101 to 150, including 150. Well, okay, so if I come down here and I look at the number line and I go, okay, so we got 100. This starts at 101, so 100 all the way up to 150. Now we want to take care of all those and 150 itself, and that should be food and water needed. Food and water. And this is let's roll. So you can see that like this, we begin taking care of these cases in descending order, we don't need to check whether the lower bound, we just need to check is the upper bound part of, well, let me start by writing my first if statement. You'll see what I'm talking about. So if miles remain is greater than 150. That's it. That's all we need to do for let's roll, right? All we needed to do is check one thing. Is it greater than 150? Then we need to roll. See out. Let's roll. End line. And then we have an else if. So if we're in this else if here, what do we know about miles remain? Well, what we know about miles remain is if this is not true, then that means that whatever's stored in here must be less than or equal to 150. So if it's less than or equal to 150, then we can ask, well, is miles remain greater than 100? Because if it's greater than 100, then that means that it's 101 to 150, including 150, right? So if that's true, then we see out food and water needed. Else if. So if we're here, then we know more things about miles remain. So here we know that it's got to be less than or equal to 150. And if we're here, then we know that, well, this must have been false as well, so it's got to be less than or equal to 100. So miles remain. What do we want to check next? So if it's less than or equal to 100, well, let's check and see if it's greater than 50. Because if it's greater than, greater than or equal to 50, we actually want to output rest area needed. So if miles remain is greater than or equal to 50, see out rest area needed. Okay, now if we do our last bit here, we need to say, well, if there's 0 to 49, we can make it. So, lastly, we have to, let me just move this down, else if miles remain is greater than or equal to 0, see out we can make it. Now, I also would have accepted, I definitely would have accepted if you just did an else here and you said, well, else it must be greater than or equal to 0. But that's not entirely true, right? What if somebody did put in a, whoops, sorry, this is getting a little unwieldy here. What if somebody did and put a negative number. Well, and that negative number shouldn't be handled here, and we should have some sort of an error message, but whatever. It's an exam. Not going to get that picky about error checking, right? But just wanted to say that would have been fine too if you did do error checking there. Any questions about this, and especially my atrocious explanation of the number line here? This all made sense of what we were looking for when we said most efficient? Okay. Now, if I scroll down, this one, so given this code above, no documentation is needed. We need to write a value returning function called isDiv5 that returns true if the entered number is evenly divisible by 5 and false otherwise. So you just need to write the function. Don't even really need to worry about this code too much. So if it's going to return a true or false, well, our data type is bool, and it's called isDiv5. And we're working with integers. That's an assumption because it's evenly divisible by 5. We can't do modular arithmetic with a float. So with that, we know there's got to be an int. So int num. And then we just say, well, if num mod 5 equals 0. If that's true, then we return true. And then we would have an else return false. And that's all we were generally looking for there. Now, did that make sense? Any questions with that? All right. Now, this one is a bit of a long one. So, rewrite the following program segment so that it uses a switch statement and indent properly. Okay. So, funny story with this one. We actually did this exact thing last Thursday, didn't we?
Yeah, I was biting my tongue about complaining about your example when I got to this question.
You know, I do so much for you and you don't appreciate it. So let's take a look at this because yeah, it's the exact problem that we had there. We have a month num, okay, that month num. So if we're gonna take this if block and convert it to a switch case statement, basically all that we're looking for is a switch month num. Whoops. And then curly braces here. And if we look here, if the month num is 2, num days equals 28. So let me just write a case 2. Num days.
And would the fall through you have shown us work for this example?
Yes, it would. Yeah. So I'm just going to write it like this so that I can save a little bit of space. You know, it all compiles the same. So now the next one, I'm just going to look at this and go 4, 6, 9, and 11. It should equal 30. Now, one thing that I did see that I would not accept because it's not valid is you do have to do case 4, case 6, but I did see a few people doing this where they do 4, 6, 9, and that does not work. Absolutely does not compile. So if I do case 4, case 6, case 9, case 11. Now here, the code fall through. So if it's 2, we'll set num days equal to 28. Then we will break out of the switch case. But if it's 4, it'll go down to the 6, go down to the 9, go down to the 11. And then here at the 11, we'll write num days gets 31. And then we'll write our break right here. And it's completely okay if you wanted to put num days equals something in all of these, but I'm lazy, so we're going to do it this way. Now down here, oh, and by the way, if anybody's wondering, yes, it does bother me that I have these cases out of order. I really hate this, but at the same time, it does make me write less, so my laziness is beating my OCD right now. So case 1, case 3, case 5, case 7, case 8, and then 10 and 12. Can I make that a finer point? Oh yeah, that's much better. Num days gets... Well, did I do that wrong? Oh, I did do that wrong. This is supposed to be 30. My fault. That one should be 30. This one is 31. So num days equals 31. And then we break. Now, this else statement here is everything that doesn't match those above cases. Well, the translation to that in a switch case statement is default. So let's do default. And then we're just going to see out month num is an invalid month. Valid months range from 1 to 12, blah, 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 blah. You guys get the point with that. Because all we were asked to do was take that if statement and convert it into the switch. So this would have been the full answer. Now, did that make sense? Everybody happy with that explanation here? Let me zoom out so I can get that. There we go. Any questions?
Nope.
All right. Man, we're doing really good. Okay, everybody's going to hate me on this one, and I apologize in advance, but let's take a look at it. So given the following declaration, give the output of the code in the space below. So here, we're given a couple spaces here. I know you guys couldn't write on it since this is not the way it was given. Get that out of the way. Okay, so num1 equals 5 is check, not set. Num2 equals 6. Letter equals A. Gets A. So we see out congrats. Okay. So congrats. Exclamation mark. And then now we output end line. So we go to the next line. If num1 mod num2 equals 5. So num1 is 5. So is 5 mod 6 equal to 5? Well, 5 divided by 6 is 0, remainder of 5, so the answer to 5 mod 6 would equal 5, so that's true. So we enter into the if statement here, and we say if letter assigned, not is equal, assigned A. Then we go in here. So this will always evaluate to true. So we enter in and we see out another n line. So we go to the next line down. And then we output U and a space. Y-O-U and a space. So we're right here right now. And then we set is check to false. So I'm just going to write a little, just going to underline this so that I remember. Is check is false. So we exit out of this if statement and we go around the else block. And now we're at the end of this if statement and we go around this else block. Since we went into the if statement, we go out of the else. And then we're here and we output R. A-R-E space. So now we're right here. If not is check. Well, is check is false. So that's true. So then we go in and we execute this cout statement and we say finished. Exclamation mark.
Oh my, dyslexic me all the way up at the top when you did num1 mod 6.
Yep.
Or like 5 mod 6. I did 6 mod 5.
Oh no.
So I skipped all of that.
Oh no. Ah, I am sorry. Yeah, so none of this would have came out right for you at all.
Yeah, yep.
Oh, be careful of that.
Yep.
This one was deceptive. Well, so you can't even be mad about this part then.
No, yeah, I can't.
All right. Anybody have any questions on this? Other than the yes, it is 5 mod 6. All right. By the way, I just want to point out really quick that when I took this before, because I just want to make sure what you guys are taking. When I took this, I totally missed that. And I went into the else. So, if you did that, you're not alone. You're in good company, I'd like to think. Okay, so now here, the last problem that we asked. So given the following program and the contents of the input file, follow the prompts to complete it. So this is the input file. So we're just pretending like it's a text file that has these lines in it, these characters. And these are all new lines and blah, blah, blah. Okay. So if we're working with a file, it says for file IO. Well, we need to pound include fstream, right? Is this big enough or should I make this a little bit bigger?
I think it's good.
Okay, good. Whoops. Oh my God. Okay. Variable declarations. So it doesn't tell us to do anything there. Declare input and output file variables. Well, first we need an input, so ifstream dn. And then now our output, ofstream dout. Now associate dn with the input file data.in. Okay, so dn dot open data.in.
You're just setting the variable, the ifstream variable to din, right? It can be anything.
No, this is not the variable.
Gotcha.
This is the data type. So this is the ifstream object, actually. If we're getting a little bit more specific here, this comes from the fstream library, and it is an object that we use to interact with files. This is the identifier.
Gotcha.
This is the technically. So what you're asking is basically, could I have called this in file or something like that instead of dn?
Yep.
Yes, you could have. But then I guess these comments would have made a little bit less sense for you. But as long as you were consistent, I have no problem with it.
Yeah, that's what happened.
Okay. I don't remember having a problem with it. Okay. Um,
Yeah, but the comments were confusing.
yes. And that's why, do you remember when we talked about this? And well, actually, I don't know if you were there. Maybe you weren't for that day when I had mentioned that the IF stream and OF stream, we called them D in and D out. And we just be consistent with that so that things like this, don't happen. Okay.
Gotcha, thanks.
So dn.open data.in. Now dout, associate dout with the output file data.out. Okay, so I'll just do a dout. I'm having trouble writing. .open data.out. Write the code necessary to read a second line from the input file and store it in the variable str line. So now there are two ways to do this. I would have taken either way. Now so I'm going to write these right next to each other. We could have done a dn dot ignore either 80 characters or until an end line character, so the \n. So we would have said we're going to ignore 80 characters or until we get to a new line character like that. That would have been fine. Or we could have done a get line. Our source is dn and our target is str line. And then when we get the second line, we're just going to do another get line from dn and store it in str line. So you see, this one would have taken two commands either way. I don't know. Either one of these would have been fine. I kind of like just, well, if you want the second line, let me get the first line and then get the second line next, right? Either way you want to do it, though. So str line at this point should contain our second line here. So stone gathers. Okay. Now when you come down here, str line gets str line dot. You'll notice this is dot substring. Sub str is the actual command, but we wrote it out so that hopefully it was a hint as to what it's supposed to do. So starting at index 2, we get 3 characters, and we store that in str line. So I'm going to reference this right here. So starting at index 2, so we got 0, remember because we started 0, 1, 2 here, and we get 3 characters. So 1, 2, 3. So this is what's stored in str line right now, is just the word 1, O-N-E. So I'm going to write that right here just so that I don't forget, O-N-E. Now write the code necessary to output the contents of variable str line to the output file. Well, that's easy. It's just like cout, except we replace it with dout. So dout str line. Close the input and output files. Okay, so dn dot close dout dot close, and provide output that will be found in data.out after program execution. Well, just like I wrote up here, O-N-E is all that'll be in there. Get this all on frame. Now, did that make sense? Any questions on that problem? No? All makes sense? I believe that was the last problem. Let me just scroll around real quick to make sure. Yeah, it looks like that was it. All right. So if there's no more questions on the exam, let me stop this.